So I wanted to show you another UAM equation that's not on your reference sheet. It's a very simple one, and I'm going to use it to derive the third UAM equation in your reference sheet. So this is position, velocity, acceleration. All the UAM equations assume constant acceleration, right? So I'll just make a positive constant acceleration, make things simple. Maybe I can make that a little better. There you go. So again, this area is going to be AT, and it's going to equal to my change in velocity, right? And the velocity graph, I'm going to assume an initial velocity v naught and a final velocity v final. And so this might look something like that. Notice we have a rectangle here and a triangle there, but all together, this shape is what's known as a trapezoid, right? So let me draw this trapezoid over here. Right? It's the same trapezoid. And let me please rotate my trapezoid. Let me see if I can do that. I don't know what button to use. Maybe I'll do it this way. Maybe this will work. Nope, that button didn't work. Well, you'll just have to do it in your mind because, wait, maybe I can do it here. Give me just a minute. Yeah, I'm going to move on. So if I take this same trapezoid and I rotate it, I'm going to rotate it this way, right? That gets me, no, forget that. I'm going to rotate it the other way. Thank you very much. Rotate it like that. So it'll look like, this is clockwise rotation. Now it looks like this, right? The long base is there, the short base is up there, and this would be the same trapezoid. Now let me start labeling things. This side was V naught in length. That's this side here, right? The longer base is V final in length, and this side was time t, right? That's this trapezoid here, right? You already know that the area of a velocity graph is our displacement, right? So this side's V naught, this side's V final, and this height is t, right? Well, if you know areas of different shapes, trapezoid actually makes a lot of sense. Obviously, it's not V final times t. It's not going to be that, right? That wouldn't work. That would get you a larger area than that trapezoid. But if you take the average of this base and this base, then you'll get something in the middle, right? And that's what the area of a trapezoid is based upon. You're just taking the average of those different bases. So half of V naught plus V final. The average of the bases, that's what this is. Average of bases. And then you multiply by time, which is the height, right? And that will get you displacement, okay? So that is going to be useful. That's not on your reference sheet, but it's a very easy UAM equation to remember. And I'll just complete the stack of graphs. Maybe the object's sped up or something like that. So again, this very simple UAM equation will be helpful in deriving the third equation. It's just a lot easier. Okay? So I'll do that in my next screencast. This is a pretty neat little equation. Again, remember what's nice about this equation, it doesn't have acceleration in it. So there's no A term. So if you don't know the acceleration, but you know the initial and final velocity and the time, you can find the displacement. It's a little dangerous, though. Since it doesn't have acceleration, you forget sometimes that this equation assumes a constant acceleration. Okay? So this is this is a UAM equation not on your reference sheet that does assume a constant acceleration. Anyway, thanks for watching.